Hi and welcome to lesson 14.3. We're talking about ordering real numbers. Now, before you learned about real numbers and the rational and the irrational numbers, now we are going to order those, from least to greatest and so on. And we're going to talk about how to do that. So, comparing irrational numbers, which, as you remember, are part of the real number system, between any two real numbers is another real number. To compare and order real numbers, you can approximate. Think about that. Between any two real numbers is another real number. Think about that for just a moment. If I have, I have an opportunity to use this. Okay, like the straight line tool. And so in between any two real numbers. So if you have, let's say that's 0 and 1. Oh, you know what? I can call it 1.12 and 1.13, and those are two real numbers. In between them is another real number, so that could be 1.125 is in between those two. So anyway, fun factoid. So in example 1, we're going to compare these two here, these two numbers. We're going to compare that sum and that sum, and which one is it going to be? Well, let's see. Here we're starting with 5, and here we're starting with 3. Before I even get to this, I'm thinking that this one's the larger sum, because the square root of 3 and the square root of 5 is not that big of a difference. So first, let's approximate the square root of 3. Okay, it's between 1 and 2, because 1 squared is 1 and 2 squared is 4. Okay, so 3 is in between 1 and 4. All right, so approximate the square root of 5 is in between 2 and 3, because 2 squared is 4 and 3 squared is 9. Okay, and that we would see right here. All right, so then we would approximate this. So the square root of 3 plus 5 is in between 6 and 7, because the square root of 3 is in between 1 and 2. So it's 1 or 2 plus 5, which is 6 and 7. And 3, and the square root of 5 is, is between 2 and 3. So you can either add 2 or 3. So 3 plus 2 is 5, or 3 plus 3 is 6. So we see here, looks like I was wrong. Oh, no, I was right. Because, yeah, right here. So this is, this was more than that. And I simply see it as, well, we're starting with 5 versus starting with 3. And the square root of 3, like I said, is not a big difference from the square root of 5. Anyway, so if we look at this, if 7 plus square root of 5 is equal to square root of 5 plus a number, what do you know about the number and why? Well, this is what we have to say about that. Number is 7, because they have to be the same. So if 7 plus the square root of 5 is equal to the square root of 5 plus 7, it's just switching this order around is what they're talking about. So what are the closest two integers that the square root of 300 is in between? 15 times 15 is 225. 19 times 19, 17 times 17. Let's see what we got here. I have it. Just a moment. And that's what we got. 17 times 17. What is 17 times 17? I gotta do that real quick. 17 times 17 is 289. So 17 squared is 289, and 18 squared, I think, is 324. Yeah, it's 324, so that's why it's in between. 324. That's why it's between 17 and 18. Okay, now we're going to compare these. Now with this, I'm thinking we're starting with 4 and then adding the square root of 2, versus starting with 2 and adding the square root of 4. Well, I know what this is. This is 2 plus 2, and this is equal to 4 right there. So that's 4. And then this starts with 4, and then we're adding something to 4. That means it has to be opening to the left. And we have, Oh, I got to do this. There, it opens to the left. And for this one, oh, dude, we're starting with 12 here versus starting with 6. That's an easy one. I mean, the square root of 12. Oops. The square root of 12 would have. I mean, for these to be. Well, the square root of 12 is in between 3 and 4. So this could be as small as 9 and as big as 10 when we're adding 3 plus 6 and 4 plus 6. So this is already 12. So that's going to be an easy one. That is here. It's open to the right. Okay. Let's see what else we got here. Ordering real numbers in a real-world context. Okay, so we're going to apply this to real worlds here, or real-world situations. So calculations and estimations in the real world may differ. It may be important to know not which is the most accurate, but which gives the greatest or least values, depending on the context. Let's see an example. 4 people have found the distance in kilometers across a canyon using different methods. Their results are given in the table. Order the distances from least to greatest. Okay. Well, let's see. What we have is we're taking a look at the square root of 28. Well, that's between, well, it's in between 5 and 6. And they have 5.2 and 5.3. Really, if I were to do this, I would just punch it in a calculator. But I don't know, I guess you might say, well, what if you didn't have a calculator? Well, we did learn how to approximate these in the last lesson. You might want to look at lesson 14.2, I believe. Yeah. So we learned how to approximate these here. But anyway, so it's about 5.3 right there. Now, and then you do this, 23 divided by 4 is 5.75. That's not too hard to do. 5.5 repeating, okay, 5.55 or rounded is 5.56. And what we're going to be doing is we're going to use this and this and this, and then the last one, 5.5, is 5.5, and we're going to use that to order them. See, that's how we have this here. So we have 5.3 is square root of 28, which is right there. 5.3 is square root of 28. And the 5.75 is 23/4, so 5.75 is right here, 23/4. 5.56 is 5.5 repeating. They're just going to throw that right there. And 5.5 is 5.5 right there. And there's the order. And we could see it by even just looking at this here. Okay. So, all right, order these distances that you see here from least to greatest. And pause the video and see if you can find out what the differences are. So, let's see. I'm going to say I have 10 thirds, which I know is 3.3 repeating. I have 3.45, and the 4.5 is repeating. I have Jose is 3.5, so that's 3.5. And LaShonda is square root of 10. Now that's the one that's going to be a little weird. Square root of 10 is about, well, it's in between 3 and 4, so it's 9. Is it halfway? No, it's going to be close. Jeez, I don't know. I guess what I have to do is I have 3.1 times 3.1. 1, 3. What? That's going to be 3, 9. It's 9.61. Okay. 3.2 times 3.2 is 4, 6. I ran out of room here. I gotta move this up. So, 6, 4. Well, that's 6, 9, 4, 2, 10.24. So it's in between 3.1 and 3.2. So I'll call it 3.15. Okay, so I have, what's the smallest? Well, I'll put this in a different color. So the smallest is going to be the square root of 10, right? This is the smallest, square root of 10. Then what? 3.3 repeating. That one's the next smallest because 3 compares to 4 compares to 5. So that's the next one's 10 thirds. And then 3.45 repeating, and then 3.5 or 3.5. Let's see how I did. I have this and 3. Oh, from greatest to least. I did the wrong. Hello. Okay, fine. Then I just have to do my order in reverse. That, then that, then that, then that. Okay, and that's what it is. Okay. Let's see what else I got. I have it right here. Ordering real numbers. You can compare and order real numbers. Listen from least to greatest. Okay, so order these from least to greatest. What we have is approximate the square root of 22. That's going to be in between 4 and 5. So since you don't know where it falls in between 4 and 5, you need to find a better estimate, so you can compare it to 4.5. Since 22 is closer to 25 than 16, use squares of numbers between 4.5. Okay, so it's more than halfway. And then we've squared 4.5, 4.6, 4.7, 4.8. We're looking for the one that's closest to 20. Let's see. Or 22, sorry, it's square root of 22. And it looks like 4.7 is pretty darn close. So 4.7 is square root of 22. Okay, then we have, so I'm going to circle that because that is an important one. And then approximate value of that. So we can use 3.14 for pi. So 3.14 plus 1 is 4.14. Okay, we're going to use that one. And then what's the last one? Oh, 4.5. 4.5 is 4.5. So here we go with this. So what do we have? 4.7. 4.7 is right here. That's square root of 22. Pi plus 1 is 4.14. Okay, 4.1, 4.14 is there. And then 4.5 is 4.5. So least to greatest is, you see it right there. Pi plus 1, done. 4.5, yes. And square root of 22, okay. So you are asked to try this. Order them from least to greatest, then graph them on the number line. So pause the video and see if you can figure that out for yourself first before I do. Okay, let's see, the square root of 5. I don't remember what that is. Well, good thing I know how to approximate that. So the square root of 5, I like using white on black. So square root of 5 is in between 2 and 3, right? Because 2 squared is 4, and 3 squared is 9. Okay, so it's closer to 4 than it is to 9, so let's use 2.1 times 2.1. That's 21024. That's 441 and 4.41. Let's try 2.2 squared. And I'm trying to find it as how close can I get to 5. So that's 4.84. 4.84. Let's go 2.3 times 2.3 is 9.664.921 5.29. So it's in between 2.2 and 2.3. Let's see, 9.664 5.29. So let's call it 2.25. So the square root of 5, I'm going to erase this here. Erase this here. And I'm going to erase all this because I know it's in between 2.2 and 2.3. So 2.25, I'm going to call it, is about, oh goodness gracious, you got to be kidding me. 2.25. Okay, and then we have 2.5. Great. And what's the other one? Square root of 3. Ugh. square root of 3. Square root of 3 is about it's in between 1 and 2. So that's 1, let's see, 1.5. So let's go in between that, 1.5 times 1.5. Oh, I know, that's 2.25. 1.6 times 1.6. I know what this is. Do I? I don't remember now. So, sorry, 1.6 times 1.6 is 2.56. Oh, yeah, of course. 2.56. And 1.7 times 1.7 is 1.7 times 1.7 is 2.89. Okay. 2.89, and 1.8 times 1.8 is 3.24. 3.24. So let's call it 1.75. So this is about 1.75. Okay, so there you go. Square root of 3 is the smallest. And then goes square root of 5, and then goes 2.5. So here you go with this here. Yes, okay. And here they are on the number line. About. Okay. Let's go with this other one here. The square root of, or pi squared. I just do not have the patience to figure out what that is. So I'm going to use a calculator, and I'm going to call it 3.14 times 3.14. So 3.14 squared. That is 3.14 times 3.14 is 9.86. 9.86, and then we have 10. Okay, whatever. And the other number is square root of 75, so square root of 75. Well, that's going to be the smallest, because this is what? 8 squared is 64, and 9 squared is 81, and it's closer, so I don't know, call it 8.6, something like that. So there you go. So the smallest is square root of 75, and then goes pi squared, and then finally 10 is the biggest. And let's see how I did. Okay, I'm right, and this is where those numbers belong on the number line. Okay. So I think that that's what I got there. Yes, that is the end of what I have for this, and I hope that this has been informational, helpful for you, and that you got something out of it. So thanks for watching. Bye.